Okay, let me welcome all of you back from the snow vacation. I hope we will not have any more big snow events for the rest of the semester. Okay, today we are going to finish up on chapter 17. Then on Thursday, we are going to skip to chapter 19 instead of chapter 18. I'm hoping that we will have time to cover chapter 18 before the next scheduled exam, which is on March 6th. Okay.
Is it going to be on a test if we don't get to it?
We will get to it. The reason I want to go do chapter 19 now, if you take a look at the previous exam that I posted already, most of the questions come from chapter 19. Okay. Also, I want to let you know that the OWL homework assignment for chapter 17 is due on Friday. That is February 21st at 11 p.m. Okay, so today we are going to finish up on chapter 17. But before we do that, let us go over the quiz questions that you guys have just taken. Yeah, Kara Wallace, can you go ahead and read this for us? Okay, thank you. You will find that most of these questions here, indeed all of these questions on this in this quiz, are basically knowing your reagents. You need to know your reagents, what the reagents do. As I always tell you, reagents are the ABC of organic chemistry. Okay? So you need to know those reagents. That is pure memorization. Okay. The first one. What do we need to do here? We want to go from a ketone to a tertiary alcohol. So what reagent do we need? Anybody? Grignard? Okay, very good. So we need Grignard. Okay. So Grignard, you say Grignard. So the Grignard you need depends on what you need to attach to this carbon here. In this case, it is a methyl group. So therefore, you need a methyl Grignard. Very good. So you attach, use a Grignard reagent. Of course, you know that we did this in, I believe this was chapter 11 or chapter 10 last semester. Okay, you take a Grignard reagent, react with a ketone, and then you follow that up with dilute acid. Then you obtain a tertiary alcohol in this case.
You don't have to put the ketone in the actual
Which one?
reagent. You don't have to put the ketone in the actual reagent.
No, the ketone is already here.
Oh.
We are going from here to here. Okay? Okay, about B, what do we need to do in B? What are we doing here? Going from a tertiary alcohol to an alkene. So what are we doing here? Dehydration, very good. And what reagent do we need for that? H264, well, that will work. Or if you simply have hydronium ion, that would be fine also. Okay? Okay, so, I mean, just knowing your reagent, that's what all of this requires. If you don't know your reagent, you can't do this. Okay? Okay, now, going from, yes.
POC L3, right?
Yes, we could do yes, that would work also. Or POCl3, phosphorus oxychloride. Generally, we use this in pyridine, but you don't need to worry about that. Okay, if you just have phosphorus oxychloride, which is POCl3, that will be fine. Okay. Okay, about going from a carbon-carbon double bond, an alkene, to an epoxide. What reagent do we need for this? MCPBA. Okay, very good. MCPBA. Of course, we all know MCPBA, that is this reagent here. See, once you know your reagent, most of your problems in organic chemistry will be solved. This is M-chloroperbenzoic acid. That is the reagent that will transform a carbon-carbon double bond to an epoxide. In other words, what this reagent does is to add an oxygen across a carbon-carbon double bond. Right here. Okay, very good. Okay, we'll come back to C later, okay? Let us do this one here, E. What are we doing here? Want to open up the epoxide? What is it? Okay. Okay, what reagent do you need for that? Dilute acid, exactly. Because you formed the epoxide already, all you need now is to open up the epoxide. Okay? Okay, all you need is dilute acid. Very good. Okay, so you need to know what this reagent do. Okay, now, about C. Anybody has an idea? Okay, well, let me give you some help here. Anytime you have an alcohol, and you take sodium hydride, think of sodium hydride just as producing hydride, which is negatively charged hydrogen. Of course, you have the sodium is positively charged. And what does it do? That hydride comes here, acts as a base, will grab this proton here from the alcohol, releasing this pair of electrons to oxygen, and now you form an alkoxide. You form the alkoxide. Of course, sodium is going to be here somewhere. Now, this alkoxide now could act as a nucleophile. So let's just take the sodium out of the picture here. That alkoxide could act as a nucleophile in an SN2 reaction. If you recall, we did SN2 reaction in chapter 11 last semester. Okay, and then you take any alkylating agent, in other words, any alkyl group that contains a leaving group will do. In this case, would be a primary alkyl group, a methyl group, or sometimes a secondary alkyl group. Okay, those are the alkylating agent that you use for SN2 reactions. So this is an SN2 reaction. So what do you have here? You have the alkoxide comes here, displays the bromine or the leaving group, and now you form an ether. You form an ether. Okay? Okay, so I've been giving you that information. What reagent do we need here to go from this tertiary alcohol to this ether right here. Sodium hydride, step 1, you do step 1, sodium hydride. And then step 2, methyl bromide or methyl iodide. Okay, very good. Let's use the iodide. Okay, and I will give you this product here. Okay, so once again, I keep saying this, you need to know what those reagents do. So my advice to you, take this quiz, use this as a template for your table of reagents, because most of the reagents that you are going to need in this chapter are actually on that sheet of paper. Yes.
So that one, could it be
C8.
308
this one here?
Yeah, where it's more to the exit.
C83. Which one? This here? Yeah, this is methyl iodide.
No, I'm saying, could it also be CH308?
Oh, no. Oh, hydroxy is not a good leaving group. You can never use hydroxy as a leaving group. No, you can't do that. Okay. So let us go to the next one. Okay, Jerome, can you go ahead and read this for us? Okay, thank you. Okay, you find that just another set of knowing your reagent question. Okay, so what are we doing here? What are we doing here? From here to here. What are we doing? We're going from a ketone to an alcohol. Okay, in this case, a secondary alcohol. So what reagent do we need here? Sodium borohydride, right? You don't have to think about it. If I give you letter A, and you have to think about what is this here, then you have a problem, right? Okay, I give you letter A, you just don't think about it. Oh, this is letter A. The same thing letter B. Those things you don't think about. Okay, the same thing you do not think about these reagents. Okay, sodium borohydride. And you follow that always, dilute acid. Make sure these are two separate steps. Do not add them together. You got to say step 1 and step 2. Okay, you could also use what other reagent? What other reagent? Lithium aluminum hydride, exactly. Okay, or step 1, lithium aluminum hydride, and then follow that up once again with dilute acid. Okay? Okay, now B, we want to go from an alcohol to a bromide. Okay, anybody has an idea what reagent to use here? PbR3, very good. PbR3. Okay, anytime you want to convert an alcohol, this time will be either a secondary alcohol or a primary alcohol to a bromide. This is the reagent you need. Phosphorus tribromide. Say that again. BBR2? Fe. No. That will not work. Okay, this is the reagent you need to do to transform an alcohol to an alkyl bromide. Now, I do want to spend a few minutes on this reagent here because it does have some stereochemical implication. If you take, let us take this molecule here. Okay, this molecule here, going back to our stereochemistry, this would be S2-butanol. Okay, you may want to work that out when you get home. Okay, this should be S2-butanol. Now, if you now take phosphorus tribromide, because this phosphorus is deficient in electron, it does not have octet of electron around it. So it does need electrons. So it will very easily act as electrophile. So, and the electron on oxygen to act as a nucleophile. Come here, attack this. So doing, you release one of these bromine here. We end up with this. Keep in mind, we have used one of the pair of electron on oxygen to bond to the phosphorus this time. Bromine is here that we release. Of course, this hydrogen is here. Methyl is here. Now, what is now going to happen? This bromide here now comes here and attacks this carbon from the back in an SN2 reaction. And that is why this reaction only occurs with a primary substrate or a secondary substrate. Okay? In other words, a primary alcohol or a secondary alcohol. When you do that, this here, this group here, this dibromophosphide group becomes a good leaving group to leave. Okay? And in so doing, what do we have as our product? We have this. Okay, so now what do we have here? We now have R2-bromobutane as a result of this SN2 reaction. So we now have an inversion of configuration. We started with the absolute configuration of this carbon was S. Now the absolute configuration now is R. So we have inverted the absolute configuration for that carbon. Okay. So therefore, if we give you this reaction, that reagent, and we wanted to show stereochemistry, you need to be aware that the reaction will have to proceed with inversion of configuration. Yes.
With the version of this configuration, so CH3 with the R2 from butane, it wouldn't be coming towards you?
Well, don't forget, when this bromine here, when it attacks this carbon, all of this here will be pushed to the other side, and that's what we have here. Okay? If If you work out the absolute configuration on this carbon, it will be R. And that is an SN2 reaction. Now, if, on the other hand, if all we did was give you this here, without showing stereochemistry, and we ask you to give the product, you don't have to show stereochemistry. All you have to do is just show that that reagent will replace the hydroxyl with a bromine. That's all you have to do. But if, on the other hand, I do this, and I say, this is the reagent here, and I ask you to give the product of that reaction. Okay? What will be the product? So you have to take account of the fact that this is an SN2 reaction, and you are going to proceed with inversion of configuration. So therefore, what are you going to have? You have the hydrogen will be going away from you now, and the bromine okay, and that will be the product. Okay, but here we do not ask you to give stereochemistry. There is no need to show stereochemistry, but you need to be aware that this reagent here, there is some stereochemical implication in case there is stereochemistry involved in the reaction. Okay. Okay, so what is the product? Okay, we already given the reagent, so this is phosphorus tribromide going from here to here. Okay, now about C, we want to go from the alkyl bromide to this primary alcohol. What reagent do we need? What is it? Robin? Go ahead. Linear, very good. Linear reagent, okay? Linear reagent. So, okay, what will be the, what kind of linear reagent? Where is your linear here? Okay, let me do this. Okay, this part of the molecule, is that your linear? Or this part of the molecule? That, okay, that part. What does linear do? What does linear do? Okay, let me give you some background. I know we did this last semester, but some of you must have forgotten this, so let us do some refresher course here. Okay, if you have a linear reagent, let us use a specific linear reagent, okay, rather than using a generic one. Let us say we use this. You know that the linear reagent, the carbon magnesium bond is highly polarized, so that the carbon has all of the negative, the electrons residing on the carbon atom. Okay, so think of the linear, therefore, as this. Okay, so the alkyl group will be acting as a nucleophile, right? And the linear could therefore react with an aldehyde, in this case formaldehyde. What does it do? Attack this right here. The pi electron goes here, and so you form this intermediate. Let me show this as blue. The formaldehyde as blue, okay? Okay. So now we have this. Hydrogen from the formaldehyde, okay? And then, after the Grignard reaction, you add dilute acid. Hydronium ion, okay? The alkoxide here, the alkoxide intermediate will now come here to grab this proton from the hydronium ion. And what do we have? We have this. Okay. Now we have a primary alcohol. So, a Grignard will react with formaldehyde to give you a primary alcohol. Supposing you have an aldehyde, a more complex aldehyde, not formaldehyde. Supposing you have this. Okay, supposing you have that aldehyde. Step 1, and then step 2, hydronium ion. Okay, what are we going to get? The Grignard comes here, attaches itself to this carbon here, and the hydrogen from hydronium ion attaches itself to oxygen. So it's almost as though you are adding an alkyl group and an hydrogen across a carbon-oxygen double bond. Okay, so what do we have here? We have this. This is from the Grignard. This is from the aldehyde, right? The aldehyde are this hydrogen here. So therefore, an aldehyde will react with a Grignard to form what kind of alcohol? A secondary alcohol. However, the smallest aldehyde, which is formaldehyde, will react with a Grignard to give what? A primary alcohol. Okay? Now, supposing we have a ketone. Supposing we have a ketone. Okay, step 1 and step 2, hydronium ion. Okay, what kind of alcohol do you think we are going to get? A tertiary alcohol. Okay. And the Grignard is right here. So in essence, the Grignard is, when you react the Grignard with a carbonyl of a ketone or aldehyde, it's as though you are adding an alkyl group and hydrogen across the carbon-oxygen double bond. Yes?
For the aldehyde, would you just get a methyl on the right side? Would you get ethane? Like, would you just get methane?
What? Oh, in this case, I actually use this. No. For this aldehyde here, don't you get what?
I'm saying, don't you get methane on one side, methane on the other side?
Why? This is from the this part is from this part is from the aldehyde. This part here,
right,
is from the aldehyde, which is this.
Right, I'm talking about the second CH3, CH2.
Oh, this one here.
No, the
This here?
Green, yeah, that's fine.
This part?
Yeah.
That is coming from this green here.
Oh, okay.
What I am doing here, using the same green here. Okay? Okay, supposing, okay, if you take a ketone, you get a tertiary alcohol. Okay? So a green here reacts with formaldehyde to give you a primary alcohol, with an aldehyde to give you a secondary alcohol, with a ketone to give you a tertiary alcohol. Okay? Now, what if we have an ester? What if we have an ester reacting with a grignard? Let us use the same grignard again. And we have this ester here. Let's use this ester. Okay, see what happens here. In this case, the grignard, you need 2 moles of grignard to react with 1 mole of an ester, and in this case you are going to get a tertiary alcohol. Let us look at the mechanism. The grignard comes here, attach the carbonyl of the ester, the pi electron goes to oxygen, and then you have this. And let us change the color here. That's from the grignard. And now this is an unstable intermediate. It will regenerate the carbonyl. And in so doing, something has got to give on this carbon here. Carbon cannot have more than 4 bonds. So the methoxy group will leave. Whatever the alkoxide of the ester is will leave. And now what do we have? Now, what is the name of this intermediate?
How do you know which group you're going to leave?
Well, very good question. If the alkyl group should leave, we go back to the starting material. So that means we go nowhere, right? But we have to explain that we want to get the final product.
So like when the reaction would take place, I guess, like I know where we're trying to go,
but don't forget the mechanism we are giving is towards where we want to go. Because if you say that the carbon-carbon bond will break, then we're going back to the starting material. So you are going nowhere. Okay. Plus, it's actually much easier to break a carbon-oxygen bond than a carbon-carbon bond. Okay. Anyway, so now, what do we get here as the intermediate? A ketone, right? Okay. What do we say about reaction of a ketone with grignard? It gives you a tertiary alcohol. So another mole of ketone will come. Grignard will come. Attach this carbonyl of a ketone this time, and then we get this intermediate. and this here. Okay. Now, once we form this is at the point at which you add your dilute acid. Okay, you add your dilute acid, and then you are going to protonate the alkoxide. This comes here, grab the, notice my arrow. You always draw arrow to show the movement of electron, where you have the electron to where you have your electrophile or where you have your acid, okay? And that is how you get the... So therefore, if I ask you, the reaction of a Grignard with an ester, what kind of alcohol do you get? Tertiary alcohol. In which two of the alkyl group will be coming from the Grignard reagent. Okay? Okay, so let us go back to question number 2. Okay, so therefore, what is the reagent we need for here? What reagent, what will be the Grignard here? What reagent, yes? Cyclohexyl Grignard, exactly. So your Grignard will be this part here, will be your Grignard. And this part here will be your formaldehyde, carbonyl, okay? So you start with cyclohexyl Grignard, step 1. And then step 2, you add formaldehyde. And then step 3, hydronium ion. Okay? And that is what you do for that. Okay? The this carbon here comes from the formaldehyde, yes. Yes, go ahead.
Do you have the exact number like that? Like what if I did 1 and then 2, I did for each
If you write 1?
Yeah, I just did 1, 2. Like I just did chlorine for H2O.
Okay. That is not complete because you only this here will only take you to the alkoxide, doesn't take you to the final product. Okay. Okay. Yes. No, you already have, that is the Grignard reagent.
Okay, so if you're number 1, if you just put anything.
Oh, I see. Well, you want to form the Grignard reagent for, okay. Yeah. I see. Yeah, that's fine. Mg, okay, I see what you're saying now. In other words, you have the Mg, that gives you the Grignard reagent. Right. So, okay, so let us do one more step. I got you. So that would be step 1, Mg, right? Right? And then step 2, that is your Grignard right here. And then step 3, you add this here, aldehyde, and then step 4 will be this here.
So my question is more that, like, do you have to show the picture of the Grignard, like,
oh, do you have to show the, no,
okay,
that's fine.
So you
yeah, if you just have Mg, we know that you have formed the, in other words, that's step 2, we know that that is assumed. Yeah. Okay, then you could then add the aldehyde, formaldehyde. That is fine. So you don't really need to show the Grignard, the structure of the Grignard. Okay, very good. Okay, about D. Now we want to go from a primary alcohol to an aldehyde. PCC, okay, very good. PCC will take.
Can you use the best one?
Yes. PCC will take a primary alcohol and oxidize a primary alcohol to an aldehyde. This is an aldehyde right here. Okay, you could use PCC or desmartin. I will show you the structure of both of them, but you don't need to write the structure of those reagents. Okay? Okay, both of those reagents will take a primary alcohol and give you an aldehyde. Yes, here. It's PCC or. PCC or. Okay, now let's spend a little bit time on this. If you now let us see here. Oxidation.
Wait, quick question.
Yeah.
CCC over CH264.
Oh, that's the solvent. That's fine. Okay, the dichloromethane is just the solvent.
So it doesn't matter.
No, it doesn't. Oxidation of alcohol. Okay. If you take a primary alcohol and you take this reagent here, chromium trioxide in acid, what this reagent will do is to oxidize a primary alcohol to a carboxylic acid. Okay, so you need to add that to your list of reagents. Okay, this reagent, what it does is to take a primary alcohol and oxidize to a carboxylic acid. That same reagent will also take a secondary alcohol and oxidize to a ketone. However, if you want to take a primary alcohol to an aldehyde, you have to use PCC or desmartin okay? In that case, you get your aldehyde. This is the structure of PCC. This is called pyridinium chlorochromate. And that is why we call this PCC, the acronym PCC. So you don't need to write this structure. You just write PCC, that is fine. Okay, for desmartin, this is the structure of desmartin. In this case, the AC stands for AC group. Okay, but you don't need to write all of this structure, just write Des-Martin. The full name is Des-Martin periodinane. Okay, but you could simply just write Des-Martin, that is fine. But what do? They take a primary alcohol to aldehyde. Okay. They could also take a secondary alcohol both PCC or Des-Martin, who also oxidize a secondary alcohol to a ketone. Okay? Okay, so now let us go back to our question here. Okay, so we say that going from here, you say primary alcohol to this aldehyde here, we need either PCC or Des-Martin. Okay. However, going from the aldehyde to a secondary alcohol, what do you need? Grignard, exactly, Grignard. Okay. So in this case, we are going from an aldehyde to a secondary alcohol. So you have to think Grignard at this point. And this will be this part of the molecule here will be your Grignard part. And this part will be this aldehyde here. Okay? That is this aldehyde right here. Okay, so therefore, what do we need? What is the Grignard, the reagent that we need? Let us write it here. That will be this here. Okay, you use that Grignard, step 1. And then step 2, you add your hydronium ion. Okay? And that is what you need for E. Okay. See that? Any blanks?
Yeah, like ones that have
Okay. Okay, let's do the last one here. F. What are we doing here for F? What are we doing? What are we doing? Dehydration. Okay, so what do you need? POCl3. Very good. POCl3.
Are you going to have credit?
Huh?
You're going to have credit.
Credit.
Yeah.
Well, each one of these is only 1 point.
You said with only 1 point?
Yeah. Each is 1 point. Okay.
Hold on.
Each one of these is 1 point.
Oh, okay. So
Yeah.
you missed one, you did, but you get another one.
So you get a chance to get extra credit here. So I will only take the best 3, so yes. Yes. In this case, you could use H264. Or okay, that would be fine. Okay, let's do the question 3. Okay, we should be able to go through this real quick. Okay, let's do this now. Okay, Jasmine, can you read this for us? Okay, very good, and thank you. Okay, so what do we need to do here? Just fill in the missing reagent, just as we have been doing in the previous questions. Okay, number 1, what do we need? Ketone to secondary alcohol. Exactly. You don't need to think about it. If you have to think, you are not in the game. This is not the part where you think. Okay, when you get to the synthetic scheme, mechanism, that is where you think. Okay.
Can you also use the LIL?
Yes, you could use. Okay.
Right, I'm trying to be in the game.
Or you could use lithium aluminum hydride for this here, going from a ketone to secondary alcohol. Or, let me say here, lithium aluminum hydride, and then step 2. Okay, but 2, what are we doing here? Going from an alcohol to an alkyl chloride, right? Okay, I'll tell you now, you need this reagent here. Thionyl chloride, SOCl2. I want to spend a few minutes on this reagent.
You're not giving us credit. We told you that.
So I want to spend a few minutes on this reagent. Okay? Anytime you want to go from a primary alcohol or a secondary alcohol to an alkyl chloride, this is the reagent you need. Okay? You don't have too many reagents like this. Okay. So, let us take a look at that reagent. Okay, SOCl2 is called thionyl chloride. I want to show you the mechanism for this reaction because it does have a stereochemical implication, just as in the case of the phosphorus tribromide. Once again, let us start with a molecule that has a chirality center. Okay, and then you have thionyl chloride. Okay, what happens? Non-bonding electron on oxygen. See, in all of these cases here, you could almost predict what is going to happen. Attach the sulfur, the pi electron goes to oxygen. I'm sorry, I just, okay, well, okay. Okay, very unstable intermediate, which will regenerate the sulfur-oxygen double bond. And then at this point, something has got to give, the chlorine will leave. So now you have this. Now the chlorine that we displayed is here, and that chlorine now will now react as a nucleophile in an SN2 reaction, similar to what we showed you with the case of, in the case of phosphorus tribromide. Comes here, attack this carbon here from the back, and this here will leave the pair of electrons, and now we are going to get an inverted configuration. So if we started with S, 2-bromo, 2-butanol. Okay, we end up with R, 2-chloro. Okay, so what we have done here, we have inverted the configuration around this carbon here. The absolute configuration here used to be S, now it is now R. So this reaction proceeds with inverted configuration. Now, if there is no stereochemistry shown, like in this case, we just have this, ask you to give the product of the reaction. Then you don't need to show stereochemistry. In this case, you just simply show that you are replacing the hydroxy group with the chlorine. If on the other hand, we have this, in which now we are showing stereochemistry, and then we say, what is the product of this reaction? In that case, you need to show the stereochemistry also. So that means that the chlorine will be here, and the hydrogen will be here. Okay? Okay, so let us go back to that question. Everybody got this? Wait. Okay. Okay, so where are we? Okay. So we've done this here, number 2. About number 3, what reagent do we need here? Mg? Very good.
Ether.
Mg in ether. If you don't show the ether, that is fine. The ether is just a solvent. Okay, how about number 4? Okay, let me help you out here. I don't think you know that yet. For this one here, you need a nitride. A Grignard reagent will react with a nitride to give you a ketone. Okay? So keep that in mind. A Grignard reagent, for example, if I have this Grignard reagent here, and I have this nitride here, step 1, and then step 2, we add the hydronium ion. Okay, this carbon now becomes the carbonyl of a ketone. So keep that in mind. A Grignard will react with a nitride to give you a ketone. Okay? Okay, and that's what you get here. About number 5, what do you have there? What is going on here? What reagent do we need here? We're going from a ketone to an alcohol. You don't have to think about it. What is it? LAH or sodium borohydride, right? Okay, very good. Lithium aluminum hydride, LAH, followed by step 2, H2 iron. Very good. Or you could use sodium borohydride, right? Followed by hydronium iron. Okay. Okay, about 6. What reagent do we need here? POCl3, phosphorus tri. Okay, you see how easy this is once you know those reagents. Okay, I could wake you up in your sleep, say, what does this do? You should tell me right away. I seen that, right?
If you in my room, you don't have a problem.
I'll be in trouble. Okay. Okay, let us go to the last one. Okay, we should be able to go through this real quick. We did this in the last chapter 16 or 15. Okay, going from benzene to this ketone here, what reagent do we need? What kind of reaction is it? Acylation. Okay, Friedel-Crafts acylation. Okay, so you take this. This is Friedel-Crafts. Acylation. Okay. Okay, but going from about number 2. What do we need? You don't need to think about this. If you are thinking, then you are not in the game. LAH, exactly. LAH followed by hydronium iron. Or you could use sodium borohydride followed by hydronium iron. Very good. Okay, now we're going from an alcohol to a bromide. What do you need? Now you don't think. Do not think. This is not the thinking time. Okay? See, it should get to a point when you be talking organic chemistry in your sleep. Okay. About number 4. What do we need here? Number 4? Mg, very good. Magnesium in ether. Okay, that will form the linear reagent, yes. Say that again. No, you don't have to put the ether, yes. Just have magnesium, that is fine. Okay, now about this one, 7. What kind of reaction is this? Friedel-Crafts acylation, exactly. So all you need here is this here. Okay, with aluminum chloride, okay? Okay, that is Friedel-Crafts acylation. Okay, and finally, you are reacting this here with this ketone, okay? And you get in this here. So what do we need for 5? Hydronium iron, exactly. So there, all you need here is hydronium iron. Okay? Okay, and finally, number 6. You shouldn't think about that. What is it? POCl3, right? Okay, POC. Or you could also use.
I don't know.
You could also use or AT250 you could use that here. Okay, in water. Okay, so I believe we have almost finished chapter 17. Yes. Number 5? No, number 5? It's, because the greener will react with the ketone to form the alkoxide. And then all you then need to do is just complete the reaction with the hydronium ion. This greener here will attack this here. Okay? from the alkoxide.
You know what reagents is.
Okay. Okay, so at this point we have finished most of, we got 2 more minutes. 1 minute, 1 minute. Okay. If you look at this here, the chart that we gave you, I think we've done just about everything here except this, right? I think that's about it. Okay, now, so let us finish that. Okay, from an alcohol to an ester. Anytime you take, we did everything. You don't think so? Huh? The esterification? No, we reacted with an ester. We did not form an ester with an alcohol to. No, that is an ether. That's an ether. Okay, if you take an ester, we will be doing this later on, so let's display. Okay, if you take this, a carboxylic acid, and you take an alcohol, say ethyl alcohol, in the presence of acid, what do you get? You get an ester. And this process we call esterification. Okay, so any alcohol, for the most part, the small, low molecular weight alcohol reacts with any carboxylic acid. In the presence of acid as a catalyst, you get an ester. And this process we call acid catalyzed esterification. Okay? And on that, we have basically finished chapter 17. When we come back on Thursday, we are going to start with chapter 19. Okay? So, see you guys on Thursday. Just a minute.